Okay, good morning, everyone. So this is our second lecture, and it's actually my favorite lecture of this course. It's a shame there are not more students around, but it was a different day today, and tomorrow is a holiday, so I understand. But yeah, I don't think I saw many of you in the geographic research, geoinformatics research days yesterday and day before. Was anyone there? In our department, we were hosting the geoinformatics research days on Monday and Tuesday. And it went pretty well. We had a lot of participants from all around Finland and also from abroad. Well, I was the main person running the thing, and I had chosen as the title, Geospatial Intelligence for Sustainable Futures, and that led to a lot of discussion. We had a panel discussion facilitated by Tuuli, and we had a number of guests. So there were two opinions. Some people thought it's a very fluffy, generic title. What is even geospatial intelligence? Some people liked it. So does anyone have any opinion about it? It's not very related to this, but you can think about it. But my way of justifying was that, well, the idea came from artificial intelligence. We wanted to highlight it because there's so much excitement around it. But at the same time, we didn't want to limit it to artificial intelligence. So we framed it that way with the idea that geospatial solutions are innovative and can provide meaningful insights in a number of smart ways. But yeah, that was a good discussion we had yesterday. And today we are going to talk about colors and visual hierarchy. A couple of years ago, when I taught this course for the first time, we were at this lecture and we had a very good discussion about colors with the students. And one of the students had a very good point. She used what I was wearing that day as an example, saying that we humans are a bit boring with colors. I remember I was wearing a white shirt that day and dark blue pants. So today I tried to be a bit more colorful. But she had a good point. We are not very creative, like not all of us, but many of us are not very colorful or brave with our choices of color. And that applies also to our maps. So today we are going to learn a bit more about colors, and hopefully we'll get encouraged to be a bit braver with our choice of colors and more creative. So the two topics we're covering today is visual hierarchy, and then we have the colors, and they're related because choice of color is a big part of visual hierarchy, but most of the time today goes to the color topic. And we have a lot of slides. Hopefully we will make it to the end. If not, we will continue next week. And we have some fun activity related to colors coming up later today. And then we have a guest talk by Tuomas Väisänen. No one calls him that, everyone calls him Väiski. But he's coming at the last half an hour of the class, and he will talk about the edge bundling tool that came up already last week. So you have an exercise and tutorial on that next week, but the talk is this week. And the reason is that when we have guests, it depends a bit on their availability. So it's not ideal, but it's gonna be useful to you, especially next week. Is the light good enough or is it too bright? Yeah, so we saw this slide last week. One of the things we try to highlight in this course is to see cartography as a form of art, and we use our technical skills and our creativity to make maps that are not only effective in communicating information, but also beautiful to look at. So let's just start with this map of Suomenlinna. So what is the first thing that catches your attention when you look at this map? In terms of visual hierarchy, like without thinking too much, what did you see first? The green areas. Yeah. True. What else? The numbers.
I think the northern arrow and that title.
That is true too. Yeah. Yeah. So that this is a good example showing you how visual hierarchy works. There are a number of things that are clearly highlighted. Well, of course, there's a lot of green that is part of the map. And we will talk about colors, and it's a bit strange why they have chosen green. But anyway, I personally think, it depends on where this map was used, but I personally think this is overemphasized here, like the north arrow and the title. Well, the title is okay, but the north arrow, then if you think about how the map is going to be used, probably it was installed somewhere in Suomenlinna or given out as these printed brochures for exploring the island for tourists. So I don't know how useful the north arrow sign is. It's good to have it maybe, but this big. So visual hierarchy. So this is an example of visual hierarchy. The choice of colors, symbols, where you place things, the size of things affects what people see first. So you should be careful with that. We looked at this map last week, and there were things we were happy with about this map, and there were things that we criticized last week. But I think one of the things that works quite well here is visual hierarchy, because the point here is to look at the tram lines, and I think we all agree that that's the first thing that pops out here. So in terms of visual hierarchy, it works quite well. So what is visual hierarchy? It refers to the arrangement or organization of elements within a design in a way that guides the viewer's eyes through the content in a specific order of importance. So the idea here is to create a clear and logical structure that helps users to navigate the map, but also get to the first things first, like important things. We looked at this last week. So the idea is that if you really want to create a map, it's an iterative process, and especially when you're deciding about the visual hierarchy, it's good to make a sketch and just see how the visual hierarchy is working. If you can get feedback from other people, and repeat this process until you get a good visual hierarchy. So this is an example of how the layout can influence. So visual hierarchy can come from a number of places, and we are going to talk about them. So coloring is one of the important things that determines the hierarchy in your map, and we are going to talk about that quite a lot today. But layout is another important thing. So the placement of things. So where do you put your map? Where do you put your legend? Or if you have other elements in your map, where do you place them? So this is the same map, just the layout is different. So the placement of things is different. And you can see it results to very different looking maps. Different things are, some of them are bad. They look bad, some of them look better, but different things are prioritized. So we don't want to necessarily say what is good or bad here, but to just see that, okay, choice of layout can really result in very different maps. So a few tips how to plan your visual hierarchy. So again, if you think about cartography, like we talked last week, there is no like hard rule how to do things, but there are a lot of like good practices and tips how to do things. And here's a list of some good tips coming from different books and literature that might help you plan visual hierarchy a bit better in your maps. But as I always say, it's a creative process, so this is not all. So a map's purpose dictates the features that need to be highest in visual hierarchy, so it's not always the same. So as a general rule, the map itself should be the top hierarchy. Like for example, we had the Suomenlinna map. The north arrow and the title were, at least for me, they were getting more attention than the map itself. And that's something that you should generally avoid, because the main thing is the map. So as a general rule, you should not overemphasize non-map elements over the map itself. But overall, the hierarchy depends a lot on the purpose of the map. Don't fill out all the corners and voids. This is a mistake that many of us make. Like you have empty space in your map and you think, okay, I can put more information here. But that's usually not a good thing. The more is not always the better. If you overcrowd your map, then you mess up with the visual hierarchy. So things that should be seen easily, they will not be seen as easily. So don't fill all the voids in your map unless you really need to put certain information. Place your most important information toward the center of the image. So when you look at the image, and there are a lot of studies actually on this with like eye tracking. Even last year we had a master's student from Aalto University who was working on this, like eye tracking, seeing where people look at when they look at a map. And usually it's around the center of the image. So if you have something that is super important, which is often your map, the map element itself, put it toward the center. So we had some examples when the map was put in some corner. That is usually not a good solution as a general rule. If you're working in software, which is often the case, no one draws maps on the paper anymore, use these grid lines for alignment, or like a QGIS other software, you also have this snapping feature so you can see the alignment, but try to make things aligned, just don't randomly throw them around. Reduce the sight lines at the map layout. Yeah, so try to align your elements in a reasonable way that people, because people usually, when we look at an image, we usually don't jump around with our eyes. We follow a logical rule. So if there are important things that should be seen in a row, then put them next to each other. So if you want the person to see the title first and the map, then in your visual hierarchy, just consider that. Don't put the map in the one corner and the title in the other corner. Follow a logical order. Eliminate, this was one of the things that came up in when we did the Flinga board last week. One of you had mentioned that the border lines often, well, it depends on the map, but very often if you have a lot of polygons, the small polygons, the border lines make it overcrowded. And then color, hue, saturation. Color is a powerful thing when it comes to hierarchy, but we are going to open that up just now. So color in cartography. So we already talked about color briefly last week, but now we are going to spend a lot of time talking about it. So color is very important in a number of ways. If you think of cartography as an art, then color as a painting, then you can, color is a powerful tool that you can use in your work of art. It's very important, very powerful for communicating information. Last week we talked about visual variables, and color, many of them are related to color somehow. And also in terms of visual hierarchy, there are colors that are powerful. They just stand out. Well, we will talk about, like, for example, color contrast. Color contrast that you will use in your map affects the visual hierarchy quite a lot. But there are also colors that just pop out. Like red color is often seen as that. If you have red color, depends on what other colors you have, but generally it's the thing that people look at first, or among the first. So visual hierarchy and color. So colors can highlight or downplay data quite a lot. So depending on what you want to highlight, you should choose the color accordingly. And the professional use of color can impact the map's communicative power quite a lot. We saw this a slide last week, and the idea is that in order to master color in your cartography work, you need to know a number of things that we are trying to cover today. There are some theoretical parts, there are some rules that we also learn about today, and also some inspiration that can come from different places. And this is also something that we are going to work on today. So color, hue, saturation, and value are the easiest means of manipulating contrast and visual hierarchy. So I would say one of the easiest way. You can work with layout and sizing, but also color is very powerful when it comes to visual hierarchy. But let's just start with definitions. So what is color actually? How would you define color? And it's important because we're going to need the details of your definition later on. Just say whatever comes to your mind. Do you have something?
How light catches your eye.
Yeah, that's the physical way of looking at color, right? Sorry?
Nature?
Nature.
As well, it's like, so obvious, like some sky colors. So
Yeah.
already present in the nature.
Yeah, okay. So that's, yeah, it's about the perception. So it reminds you of nature, for instance. Yeah. Yeah, so this is the definition we are going to use. And we are going to define color in 4 or 5 ways today. So one of them, like we already talked about a couple of these. So color is light, so there's a physical aspect. and we're going to talk about this briefly. And then there is an aesthetic experience, the artistic side of color. So it's not just, well, there's a physical side, like how the light reflects off of different surfaces and what wavelengths is absorbed and what is not. And that's, physically speaking, that's what color is. But there's an aesthetic experience. So how do we experience colors? What kind of emotions do they carry or communicate with us? So that's another thing that we are going to talk about quite a bit today. And then there's human perception. Like, as humans, how do we perceive color? And there's a biological side to that. We are going to talk about it briefly because we're not biologists, but it helps us understand, like, how do we see colors and how we should take it into consideration. And then there's a theoretical side. So the color theory that we are going to talk about in the later part of the lecture today, and then how to work with color systems and a bit more technical things. So through these 4 or 5 dimensions, we are going to hopefully have a good understanding of color by the end of this week. So let's just start with the physical aspect of it. So light comes to our eyes either directly from the source of light. So you have a light bulb that is in a certain wavelength, and when you look at it, it might seem, depending on wavelengths, you might see it as different colors. Or it might be reflected from a surface that determines the wavelength of the reflected light. So the light is coming from another source, from the lighting in the room or from the sun. And depending on the qualities of the surface from which the light is reflecting off, you will see it in different colors. So this appears as white to me, this table, this blackboard appears as some dark gray color to me. So that's the physical quality of the object we are looking at. So physically looking, that's what color is. But the way we see it is a bit different. It depends on how our eyes work. So there's this perception side of things as well. So I'm not a biologist, but I just know I've learned enough to know how colors work or how we see colors. So generally speaking, we have 2 types of sensory cells in our eyes. So we have rod cells, which are mostly in charge of seeing the intensity of light. So they cannot distinguish what color you're looking at. They just tell you how intense it is. So if you didn't have this other type of cells that we are going to talk about, you would see everything as grayscale. So that's what it is. And what is important for us is how the curve is actually working. So the colors, so where the curve is peaking is the colors that appear as most intense to us. So somewhere between green and yellow. So even in darkest, when it's dark, the other type of cells that we will talk about that are in charge of distinguishing colors, they don't work so well. And we know that by experience. When the light is not good enough, the colors don't look as vivid. Like, that's the experience we have, like, most of the time in winter here. When it's not so bright outside, everything kind of looks gray. But you can still see the intensity of the colors. And that works best for an average human around 550 nanometers in wavelengths, which is around yellow and green. So this pops out as quite intense. But when it comes to colors, it's a bit more complicated. We have another group of cells called cone cells that help you distinguish different colors. So they're categorized here into 3 groups of the short wavelength, medium, and long. And they overlap quite a lot because it's just complex how it works, but your brain has a way of just deciphering this. So what we want to learn from this is that we experience colors in different ways, and the width of the curve here kind of tells you how sensitive your eye is to different colors. So if you can see the red one is very wide. What this means is that your eyes are very sensitive to seeing color red. So if you make small changes in color red, your eye can usually pick it up better than when you're making changes to blue. So if you have different shades of blue, it's a bit harder for your eye to distinguish them compared to different shades of red. And with the middle wavelength is somewhere in between. And as I said, for seeing colors, for these cone cells to work properly, you need to have enough light. So what does this mean to you as a cartographer? Well, first of all, color red is very powerful, and we're going to talk about that more. And another thing is that colors don't work as effectively when you don't have enough light. Well, as geographers, geoinformatics experts, you will land amazing jobs in future. Some of you might end up making maps, for example, for a museum where the lighting may not be, or depends on type of museum, but sometimes they have these darker rooms. Then if you're making a map for that kind of setting, then it's good to remember this, that the colors don't work in the same way if your map is going to be shown in a darker room. So just keep that perception side of things in your mind. And another thing that often comes up in cartography classes is the colorblind issue. So there are a lot of people, more than you think, that have color blindness. It's more common among men. I personally know quite a few people who have it. So there are a number of, they have some limitations with how they see the colors, but the classic one is that they cannot see the difference between green and red so well. So that's one of the things that people can easily criticize in your map. If you have both red and green, it can be hard for them to distinguish, but at the same time, it's a bit hard to avoid it because green is a color that you use quite often in maps if you have green areas, for instance, and then red is again, common color. The point here is not to use them together, but if you have two main elements that have to be distinguished, don't distinguish them by red and green because it's going to be problematic. The map will not be usable for many. So that's not the contrast you want to, that shouldn't be your main contrast. And it's not only red and green, it's just, there are many tools that allow you to like simulate how the picture would look like to a colorblind person. Even like AI models do it quite nicely now. So if you want to care about people who have problem with seeing colors, and that's something you should consider, especially if you're making a map for a bigger audience, then test it. Use those online tools or use AI and see how your map would look like to people who are colorblind, and then judge it. Like, is it still usable for them or not? Yeah, so the artistic part of color. So color is also an aesthetic experience. So we are looking at maps, and it's kind of obvious when you're looking at a piece of art, when you're looking at a painting. But with maps, many of us may not have thought about colors in our maps as an aesthetic experience, but that's something you cannot avoid. As humans, we have certain feelings towards certain colors. So whether you have an intention in using a certain color, the feeling is there. So it's good to be familiar with it. And maybe the best way to understand this is to look at art. So yeah, so this is a famous painting by a French painter from 19th century. Some of you might be familiar with this painting, some of you may not be. But if you just look at the map, at the picture without any colors, the painting itself might give you some feelings, but the color can give you a hint what is happening here. So the color palette that the painter has chosen is more on the cool, sad side, which is the main information or the message that the painter wanted to convey in this painting. So the color itself is giving you a bit of like sad feeling. So a very similar palette of color has been used here. This is a map I found somewhere. It's on LinkedIn. So when I upload this video, like the slides, I have to remove these maps because I've gotten them from different sources. But yeah, a very similar color palette has been used here. And to me, I'm curious to know what you think, but to me it doesn't work because it's very random, the choice of color here. And it comes with that calm, a bit melancholy kind of feeling that is irrelevant. It's a map of shipping density. So I feel like, I'm curious to know what you think, but I feel like it's a bit not the most tasteful use of color. I hope they don't find this video, the creator of this map later, but yeah, so it is a bad example of choice of color. Just think about that sentiment that might come with colors. So this is a painting by the actually same painter. It's actually not a painting, so he was also making graphics for advertisement. So this is a poster from for a place. So it's a poster for an event at a place. So the same painter who was trying to convey a sad feeling through this map was aware that, okay, this is a different purpose. I want customers to show up at that cabaret or wherever that place was. So how should I draw people's attention? This is advertisement. So the person has used big contrasts, so you can see black colors, and then there's this very vivid red color and orange. You see a high concentration of warm colors, which are more attractive, more inviting. So the painter was very aware of using colors, of course. In different contexts, has used made different choices. This is a photo, not a painting, but yeah, this is of the journalist and activist from Russia who had worked with very different things. But when they were publishing this, is it like Amnesty International or where? Yep. So when they were publishing this photo, she had passed away, so it was her anniversary or something. So they printed this in black and white because she had passed away. But at the same time, they have put a map of Russia and they have painted it in red because of what she was working on. So they have had intentions with their choice of color, going with black and white, and then using a red color on the chest. Even the placement of, I read about this picture, it's not only my own interpretation. Even the placement of the map on the chest was intentional. Like, so we looked at color through 3 different lenses already. Now we want to look at color as a theoretical thing. Yeah, so we have color theory. And a good way of understanding, there's a lot of text that you can read later on, but a good way of understanding color theoretically. So a big part of it is inspiration and how you feel, but sometimes you are clueless or you're not so experienced with colors or you're not very good with colors and you want to approach choice of color a bit more systematically. Luckily for us, there are all these like color theories that can guide you how to choose your color. So you will know what color works better with what color. So there are these rules that we can learn about. So there's this concept, this color wheel. There are many different versions of this that you can see in different books, in different software. But this helps you a lot in you choosing colors. So now I could see that when you were choosing color in PowerPoint, you were using different kinds of palettes. But when it comes to cartography, this wheel is particularly useful in choice of color. So if the option is available to you in the software you're using, then I advise you to start from here. And we are going to talk about this. So the idea of the color wheel comes from, well, many people have talked about it, but books say that maybe one of the first people who came up with the idea was Isaac Newton, who is mostly known for other things. But he had the idea that, okay, when you have a prime, you you can create this I lost the word. What is the name of this spectrum? Yeah. This color spectrum. So he was thinking that, okay, we can think of colors a bit similar to as music. So in music, we have notes and things repeat at certain distances. So he had the same idea that we have the similar kind of harmony in color. And if we draw this spectrum as a circle, we can show this repetition kind of, this loop. And it works quite nicely. And we are going to open this up and see how we can actually use this in our work. But that's the idea. So this spectrum has been translated to this circle or projected to this circle to show that harmony between colors Yeah, so we are going to open this up soon, but from this, why this wheel works well, because you can see the relationships very well. For example, colors that are opposite each other in the wheel, these are called complementary colors. So they usually give you good contrast, but they also usually look good next to each other. So, but we are going to revisit that soon. So about color wheel, when you do a bit of search, well, I put good to know because maybe you don't want to use this as your source for your cartography work, as it's more a bit philosophical, but the German polymath and philosopher and writer, he had also his own version of color wheel, which was a bit more, it was more about feelings than the color theory itself. I learned about this actually in one of my classes. We had a German student who knew about this, and I did a bit of research. So there is this as well. Yeah, so as I said, when you're choosing your color in different software, PowerPoint, QGIS, ArcGIS, you have different interfaces for choosing your color. And there are different things you can adjust when it comes to color. You have saturation, you have hue, you have lightness. So we briefly talked about this last week. So hue is basically different colors. And then you have lightness, which is the intensity of color. Then you have color saturation, which is adding impurity to the color. So usually add a bit of gray to the color. So you have pure red on top, if you look at the left side of the spectrum. You have pure red. As you go down, it becomes more grayish. So you're adding a bit of impurity. Now it's, of course, digitally, but before, in old days, or even now painters, when they want to add saturation, they have a red color, they add a bit of gray to it. You can add saturation in different ways. You can add different colors, but usually it's some shade of gray. Yeah, so hue is basically different wavelengths resulting in different colors. Then you have different intensity, and you have different levels of saturation. Of course, as we talked last week, different hues are usually used for very different values, like nominal. So you have land use, you might have residential areas as gray, green areas as green. So they don't have hierarchy, they're just different. But with brightness and saturation, you can show a bit of hierarchy. So if you have like continuous values, for example, in a density map, you can use saturation or brightness. So these are same colors in different levels of intensity and saturation. So you can see they look quite different. Of course, the way you see it also depends on where you're showing it. Are you going to print it? Are you going to show it on a screen? And we are going to talk about the media for map later on in another lecture. But yeah, same colors, but at different saturations and brightness levels. Okay, so back to the color wheel. As I said, from the color wheel, you can see the relationship between colors, and that's a nice thing. So how do we choose colors? Again, we have examples from paintings, and we will have maps coming soon. But yeah, so choice of colors. So if you want to choose colors, one of your options is to go with analogous colors. So these are colors that are similar. So what do they mean? When you look at the color wheel, they're near each other. So they're neighbors in the color wheel. They usually work well because they are quite close in the spectrum, in the wavelengths. They match quite well. So analogous color palettes are similar to one another and are close to each other on the wheel. And it can be used if you don't want a lot of contrast in your map. You can go with analogous color for certain elements. So not your whole map needs to be all in analogous colors, but for certain features, you can go with colors that are close to each other on the palette. Sometimes you may want to go with complementary colors. Complementary colors are located directly opposite of each other in the color wheel. So if you remember the color wheel, if you go for any pair that are opposite each other, these are called complementary colors. So they usually look nice together, and there's a lot of contrast because they're coming from the opposite parts of the color wheel. You have good contrast. So if you want good contrast to distinguish a certain feature on your map, and you want to make them work nicely together, then one option is to go with complementary colors. So unless you have a better idea, if you want to go by theory, just look at the color theory, choose two colors that make sense and are also opposite from each other, then you will probably end up with a good contrast and the colors probably would work well together. Yeah.
Like green and red might not work with green and red color blindness. Like that blind people.
Yeah. Yeah. So it's a guideline. That's a very good point. It's a guideline, and not all of them might look nice to you. So you have to still use your sense in choice of colors. But this is a guideline that can tell you, give you some idea what colors to choose. So this is a map, but it's not. It's more like artistic work than a map. But I like how the colors are working. I like the combination of this dark blue, red, and a bit of dark gray, black background. Then we have your choice of colors can be polychrome, which means that it's basically all over the place. So you can pick colors that work. So for colors to work nicely together, they don't have to be necessarily analogous or complementary to each other. You might just choose colors from here and there, but they work nicely together. So you might end up with a choice of color that is like this. They're from all over the color wheel. But again, it's a matter of taste, but I think in that painting, in that poster, it works quite well. Then we have monochrome colors that are just as they sound, palettes with a single color that's using, so it's basically you go with the same color in your map, you just adjust the intensity and saturation. So it's monochrome. It's basically one color at different intensities or saturation levels. Again, this depends on what you want to do in your map. So if you have a density map, intensity map, you might use this to some extent. Then we have neutral colors, colors that do not really stand out much. So we have gray, we have this beige color. There are a few examples of this, but these are good, for example, for like background elements that you don't want to like highlight so much. For example, you have a base map or you have some elements in the background that they are not the core of your map. So you can go with a color that is a bit more neutral. So the attention goes to the elements that you want to be actually noticed. Okay, so let's go through this quickly so you remember what we just talked about. So we have analogous colors that are close to each other on the wheel. We have complementary colors that are opposite from each other. They have a lot of contrast. Polychrome, just all over the place. And then monochrome is the same color at different intensities and saturations. So now let's look at some, and then we have neutral colors. Now let's look at some maps and see if we can identify which kind of combinations we have. So what do you think we have here? What group of colors has the cartographer used here? Yeah, so we have analogous colors. So they're quite close to each other on the palette. And it works well. It's actually made here in Digital Geography Lab. So this is a kernel density map. And what colors do you think are used here? They're complementary. Of course, if you look at like red and yellow, they're more like analogous. But generally, what stands out is you have this contrast between blue and yellow, red, which is working nicely here too for a density map. So yeah, so we have complementary colors here. And this? Yeah, so here the colors are a bit like all over the color wheel. So a bit more creative, but again, it's a matter of taste, but at least it's an interesting looking map. So even if the inspiration is coming, like examples I showed you so far were mostly paintings and artwork, but you can get the idea. So if you like the color in that poster from Mexico, so if you like the color combination, you might end up with a map like this. So you can get the inspiration from anywhere, basically. So, and this one, what do we have here? It's a monochrome. So we have just one shade of color. It's a boring looking map, but does the job maybe. And what do we have here? Yeah, so we have a combination of things. So we have like different shades of blue, so it's analogous there. And then what is working like quite nicely here maybe is the background, which is a neutral color. So here the focus is not on the background itself, but is on the lakes. So the creator of this map has chosen some neutral color in the background, so it doesn't get as much attention as the lakes. Yeah, and if at any point if you have questions, of course you can just interrupt me. Yeah, so aims in choosing the colors and the entire map. So we have been talking about the artistic side of things, but let's not forget that we are producing a map, and we shouldn't forget what is the main goal in a map. So you want to be clear, not just artistic. You want to think about the order, the balance, the contrast, the harmony. So there are many things you should take into account. So there are different versions of color wheel. Just when you're choosing your color, you can use it as a guideline. So on the color wheel, you can also identify colors which are more on the warm side or more on the cooler side. And again, there are different feelings attached to warm colors. They might be more suitable for certain elements in your map, certain kinds of features and values. And then we have cooler colors that have different moods. And we talked about that a lot already. And these are the complementary colors that we looked at. They're opposite from each other. And then we have many variations in between. So we have complementary, we have a split complementary. So it's like this. So they're not exactly opposite of each other, but kind of. And then we have the color triad, which, so if you want to choose like 3 colors that work nicely together and give you good contrast in the map, it's a common way of doing this. So finding 3 colors which are equal distance from each other on the wheel. So it's just an example of 3 colors. Now here it's like purple, orange, yellow, but you can choose it from anywhere on your color wheel. So if you need 3 colors that have contrast and look nice together, color triad can be one option. So colors in maps, there are a number of considerations. So we already have some idea how to come up with the colors, but let's look at the considerations as well. So think about contrast. High contrast aids map readability, ensuring features stand out distinctly. Contrast consideration affects both color choices and special elements differentiation. Yeah, so use contrasting colors for important map elements versus the background, like the example you see here. Yeah, another thing to think about is color blending and perception. Like when it comes to colors, it's unless you have an analogous color with a single color or single shade of color, often you have a combination of colors. And it's not only about how colors work individually. You should think about how they work together, because sometimes colors next to each other might affect your perception. So that is also one thing to think about. So it might affect how you see color. So this is an example that you can find better versions of this on the internet. It doesn't work super well on the screen, on the projector. But this red and that red are the same, exact same color. But here it looks more neon vivid. And I haven't changed anything. It's just here when the red is surrounded by this dark blue, you just see it as less shiny. So it's not just the color you have chosen, but what other colors do you have next to that color, because it can affect how you see the color. I'm sure on the internet you have seen so many examples of these visual errors that we make. Many of them are about colors. So it's not only about the choice of colors, but also the arrangement in your map can affect how you see the color. So here the color A and B are the same, but your brain just fools you into thinking that they're different colors, unless some visual clue has been added. Then you start to see they're actually the same color. So I'm sure you have seen many of these examples that are not necessarily map related, but in maps you're creating a visual, so you might encounter such cases. And back to our Mondrian example, and about color associations, then different composition can give you different vibe. So we already saw these colors in some of your work. That, well, again, it depends on culture and context and many things, how you see the color pink. But some people, the picture on the right might be seeming a bit like chic, playful, some things with a bit of 60s vibe. On the left, it might look more like cyberpunk, high-tech kind of image. So this pink is the same pink, it's just what you have around it is different. So that in that case, we have pink together with beige color, that might give you that kind of vibe. And then together with black, it might give you a different kind of feeling. Or it might be energetic. I guess your energetic group, you had to use some similar. Was it so? Some black and pink contrast. But anyway, so it's not only about the color you choose, but what you have around it and what is the composition. And this is something that already came up, is cultural considerations. So colors have some meaning attached to them very often, but these meanings are not always universal. So in different contexts, they might have different meanings. So colors can evoke feelings and conditions, but these are not often universal. Yeah, so yeah, there's a this is a page from a color book I was reading a while ago. So in certain Native American tribal populations, purple represents wisdom. But then in some Southern European countries, I guess in Italy, purple is a bit like mourning color, funeral color. In some cultures, purple is like associated with like monarchy and kingdom. So in different cultures, it might have different meanings. And we already talked about color blindness, but again, as a reminder, that's one of the considerations when choosing the color. So even if they're complementary or they look nice in many different ways, it may not work so well. So many of us here might see the number in the middle, but for some of us here who might have color blindness, you may not be able to read the number in the middle. So take that into consideration when choosing your colors. And then remember that too much is too much. So at the end of the day, you're creating a map. And as I said, your point is to create a clear map that is easy to read. So when choosing colors, just don't overdo it. So one last thing about color is the technical side of it. So how do we, the systems that help us work with colors, for example, in software. So there are many systems for colors, but usually you come across these two systems. So we have the RGB, and we have the CMYK. Do you know what's the difference? Or what's the difference in the logic? So the RGB is an additive color system. So the idea is that you start with blackness, so there's nothing, there's no light. Then you start adding light. So you add color. So you start from black, then you add light. So you add color. So it works well with light-based systems. So that's why we use RGB in like computers and on the screens. So if you're making a map or a visualization that is meant for computers, very often you work with RGB color system because it works nicely there. Yeah, so again, the idea is that you have blackness, then you add a bit of yellow light, then if you want to get another color, you mix the yellow light with another color. That's what you end up with. But the logic in the subtractive system, which is this CMYK, is the opposite. So you start with everything there. So you start with white. So this is meant for printing. So often you print on white surface. And what is unique about white? White reflects the full spectrum. Like why does the sun appear as white, like the color light? Because it's the full spectrum. So here you start with the full spectrum, which is the paper that you're printing on. And then you make the paper pink. What are you actually doing? You're removing some wavelength from the paper, the color that is reflected from the paper. That's how you end up with pink. It's not a full spectrum anymore. So you start with white, then you remove color. So that's the logic. So you don't need to necessarily think about it when you're choosing color, but that's where the logic comes from. And that's why this is called additive. So it's black, then you add colors, light, you mix the lights, the red and green and blue, and you come up with colors. The logic in the subtractive is opposite. So you have white, the white paper. So this was meant for printing. That's why the logic is like that. You think about it, you're printing on white surface. Usually, you have to make adjustments if you're printing on a, I don't know, colored paper. Yeah, so we have these two systems. So we have the RGB, and then you put them together, you end up with the real looking image. Or we have the CMYK, in which you have the colors that cyan, magenta, yellow, and key. And then again, you mix them and you end up with the real image. So the main point here, there's a lot to learn here if you're curious, and there's a lot of information online. But the main point in here is that when you're making your color choice in the software, in QGIS, Photoshop, any software, when you're exporting the map for printing, then you have the choice of choosing the colors in RGB system or in CMYK. If you want to print it on paper, go with CMYK, because if you go with RGB, you print it, it may not look exactly the same and you will be disappointed. With CMYK, it's more likely that you end up with a result that would be close enough to your original imagination. But we are going to talk about map media later, so this will be more clear, hopefully later. Yeah, so this is the color gamut. It's about, so the entire range of possible chromatics displayed using the three primary colors. So computers, as I said, work with RGB, and not everything can be shown. So there's a bit of limitation when it comes to what you can show on a computer screen. But there is a golden zone where things look reasonably well. So again, there are a lot of details involved, but if you end up working with, we are going to talk about map media later, but if you are working with maps in future and you're going to show them on big displays in a museum, or I don't know, you're going to make presentations, then you may want to learn more about this. For example, if you're making a map for a big TV or a screen somewhere, these are things you should take into account, and there's a lot of information out there. Yeah, so we already talked about RGB. This is a system that is used in electronic devices and screens. You mix colors, you get new colors, and you define RGB. So in the computer, you have three values. You have RGB, red, green, and blue, and you assign a value 0 to 255. So for example, full red is 255.00. So no one is going to remember that, but you find the color symbol, you find the code, and when you're printing, you remember, okay, this is the color code I want. There are other systems for color code. So we have this hexadecimal code that you probably have seen, especially if you have, well, you see it in the software, but also we use it a lot if you are using Python, for instance. And it works nicely in HTML and CSS. So it's the same RGB, it's just coded differently. So if you want to tell the printer what color to use, you should either give the RGB code or the hexadecimal code to get that exact color. But these are for screen, so it's RGB. For printer, you should go with the other system. Yeah, we talked about this already. Yeah, there are some other color systems as well that we don't use so much. So if there's HSL and HSV color models based on hue, saturation, lightness that I personally haven't used much. But if you come across those, just remember that they exist and there is some information you can find online. Yeah, so I will leave this here. Yeah, so for your exercise this week, well, there are a lot of, you can find this color picker anywhere in any software. If you just also search online on Google, I guess Google will have some pop-up tool for it. But also on the course's website, we have put some interactive version of this that you can use. And in your exercise, you will be playing around with the colors a bit. And the tools, the one on the course's website or any tool you use, they usually give you color codes in different systems. So now here I've just chosen one color, and you can see it gives you different codes. So it's the same color, just different system. So if you're printing, go with the CMYK. If you're going with a screen, RGB or other versions. With HTML, for instance, hex code works well. Yeah, and GIS software have good implementation of colors. So you have a wide range of choices, and they are interactive, so you can easily choose the colors. And also, if you use Python, if you're using programming, of course, you don't have this user interface, but then again, you have all those other tools available online or in different software. So you can check the color somewhere else and bring them to your code. Yeah, this is something that many people say. I personally don't 100% agree with this, but it's a famous thing, so you should also hear it. There should always be some red on the color, color on the map. And the main reason is it's not a hard rule, it's just something cartographers say. And the reason is that red draws a lot of attention. So if you want your map to get noticed, having a bit of red somewhere is good. But then red is powerful. If you have color green, it might be problematic. So don't feel obliged to use red necessarily. Yeah, so these are the primary books I've used for this lecture. And if you're interested to read more, there are a lot of different resources.
All right. Sorry to break everybody's flow, but I was kindly invited here by Kamir to give you a presentation on a map that I've made, kind of hopefully building on whatever you've learned today about visualizing maps using kind of color theory, visual hierarchy. And yeah, my name is Tuomas Väisänen. Maybe some of you know me from teaching the Introduction to Advanced Informatics course. So hi all, if we see again some familiar faces here. I'm a postdoctoral researcher at the Digital Geography Lab, and so been here for a while now. And my presentation is about exactly this, visualizing 2.5 million mobility flows across Europe. So a couple of lines, and then kind of before we go, and sorry for kind of reusing some of the slides from my course, so bear with me. Making maps is fairly simple, isn't it? So you have some sort of question that you want to explore or present, then you select some data, you choose a visualization method, you build a layout, and then you have a ready-made map and somebody will be interpreting it. And it sounds very kind of simple, but as all of here potentially know, it's rarely the case. So it's basically you're going across the steps, like forward, backwards, and kind of you might actually do everything, and then you end up with the map, and then you realize that you have to go back just when you realize, okay, I'm not actually exploring the questions the way I intended or presenting the results the way I intended, and kind of just this kind of iterative process is kind of characteristic in map making. So you kind of start with some questions and start with some data and then try different visualization methods, different selections of data and all this stuff, different layouts, and then eventually at some point you might end up with the map. And then the happy map reader will get to see your hard work or the fruit of your hard work. So just to make it crystal clear. So if you're struggling with this and it seems like everybody has a really nice pipeline to make a map, it's like never really the case, at least not for me. And I've done quite a lot of maps already. But like jumping from that, so when you think of when you're making a map, so what is the purpose of the map or the function of the map? What should the map do? Just raise your hand or shout, like not necessarily shout, but say say what you, yeah.
Show a phenomena in a visual way.
In a visual way, yes. Anything else?
Give us some information.
Yes, give information, yes. Any others?
Some directions.
Sorry?
It shows some directions, some locations.
Yes, can do that as well. So could we maybe distill the function of a map into communication? So there's some sort of geographical information that you want to communicate to the map reader. So in a way, maybe it's exactly direction. So this is the route to go to that place, or this is where all the population lives, and this is where kind of where the natural areas are. And like what you said about the kind of visual way, yeah, that is very true. And kind of jumping off on that, a map obviously has to communicate information, but it's not very efficient if it's not nice to look at. So you kind of have to make your map nice to look at. And this is presumably what you've been learning kind of today, using kind of this color theory perspective, like the color wheel, and kind of these different ways of choosing colors that are kind of complementing the primary colors and whatnot. So that is one way to kind of support making a beautiful map. So just to make it kind of super simple, so while making maps is generally like a mess, you're just jumping between like different steps of like selecting data and visualization methods and maybe even readjusting the question. Making a good map is actually fairly simple. You just have to be very kind of clear on what the message of the map is. If the message of the map is where the population is, then you shouldn't really put much emphasis on where the airports are or where the rivers are or whatever it might be. So kind of when you're making the map, thinking about what the map reader should be kind of taking from the map and supporting that so that the map reader receives the intended information. And then obviously making the map nice to look at, because if it's a nice and a beautiful map, the map reader will be spending more time looking at it. If it's just like awful looking, like the colors are just hurting the eyes and like it's really nonsensical, then people will just gloss it over and not even spend time with it. So then information is not, so you're kind of then you're failing the both kind of these functions of a map. And as you learned today, so kind of making a good map can be supported by applying visual hierarchy, and kind of similar to text, maps have this reading order that is very intuitive. Like obviously text, like depending on what type of text you might be reading it, like from top to bottom or left to right or right to left, doesn't matter. There's still a reading order, but maps are a bit different. They're visual, and then kind of this visual reading order is then exactly dictated by visual hierarchy. And just to kind of hammer this point home, this is exactly kind of guiding you to read a text in a certain way using kind of visual cues. And this is exactly what you can do with a map by kind of making something more prominent and something less prominent. So you will guide the map reader's attention to something that you want them to see first, and then second, maybe third, and then some background information. And a good example of visual hierarchy in maps is from a book by Krake and Ormeling called Cartography Visualization of Geospatial Data. I think this is available from our library. But here's an example of poor and good visual hierarchy. So I think it's a map of the Netherlands, if I'm not mistaken. And as you can see in the poor map, like the brightest or the most, the colors that pop out most are like the sea, and then the other countries, not even Netherlands. So kind of what is important is not like visually really kind of, it's not intuitive. Whereas in the good map that is on the right side, it's clear because there you have these bright red circles. I guess they, I don't know, designate population sites or whatever. And kind of they're clearly the top one that you should notice first, or you are noticing first. Then it's actually Netherlands, kind of secondary in importance because the map is about Netherlands and not the other Benelux countries or the sea. And then obviously after that it's the sea and so on. So, and I really like kind of this illustration of visual hierarchy here, kind of showing you how to layer things on your map. So onto my actual map. So a bit of background. So it's like why I ended up making this map, or actually I've made many maps of the same type, but still I work in a European Union project called MobiTwin, basically, and then in that project we are mapping these regional mobility flows across Europe from 2010 onwards, roughly. We're focusing on all kinds of mobility flows, not just migration, but then student mobility, which I'll be focusing on today, but then also commuting patterns, seasonal work patterns, and multi-locality. That is meaning basically people who have secondary or third homes. Many in Finland have a summer cottage. That's basically multi-locality. So people spend time in 2 different places throughout the year. And specifically, my map is about Erasmus student mobility data that is nicely published by this Directorate General of Education, Youth, Sports and Culture. They publish these annual statistics as Excel files. And because they're Excel files, then you have these textual origin and destination names in that data. So basically you have the institution, the city, and the country for origins and destinations. And it wasn't geographical because it's textual. So what we did in the project, we geocoded the data to make it spatial. And if you're interested in the data, then there's the QR code, and we even made a publication about it. If you want to take like a closer look on that data. So kind of focusing on this Erasmus student mobility data, and I wanted to make a map of the data to kind of understand how these mobility flows are kind of distributed in Europe. And I started thinking, okay, what is the main message that I want the map to have? And obviously it's student mobility flows, and this is a very kind of early map. So I wanted to know, okay, where are the main flows? Where are the kind of moderate or intermediate flows? And where are kind of these, let's say, minimal flows? So where people are like only a person or a few people are moving between regions. So I wanted to make a map that kind of shows kind of the hierarchy of the flows. So obviously it's in Europe, so I had to start out with a map of Europe. And to select these colors, if you're wondering, I was lucky enough to have in our project like this brand book where they had like some project related colors. So I picked one that I liked, which is kind of this, I don't know, teal, green, blue color. And then I used a tool called Peloton. It's an open tool on the internet, peloton.com, and that's where you can actually kind of use the color wheel and to find kind of all these kinds of complementary colors and triadic colors and whatever. So I chose kind of it's very poorly visible here, I'm sorry, but I chose this kind of very dark teal color here as kind of the main map, and then I found that, okay, we have some kind of lighter colors of this, or lighter shades of the same color that I would then use for the, is there a laser pointer? Oh, yes. So for these kind of borders of the countries and the countries themselves. And okay, it's very poorly visible here, but then like to support kind of these primary colors, it's suggested with this triadic view, it suggested, okay, like the supporting colors, there would be kind of this golden color or this purple color. And I'm kind of partial to purple in many cases, so I chose the purple color, and I wanted to put the map or the data on the map. And I was a bit shocked, because when you put 2.5 million lines on a map, no matter like how large the area is, you just get this hairball that doesn't really show you anything. Okay, then I wanted to, okay, maybe the line is just too wide, so let's reduce it, okay, a bit better, but still not clear, not beautiful, just a bunch of lines. So let's reduce them even further, okay. This is now like, I think 0.01 line width, and it's still like barely legible. So okay, you can see, especially kind of in the periphery, you can kind of see, okay, there are some kind of regions all over Europe where these mobility flows are like either starting or ending at. Starting from or ending at. Okay, not really helpful. So okay, let's maybe add some categories there. So if the flow has many people kind of going between these regions, then it should get a brighter color and a darker color if it's like very few people going on. Okay, a bit better. You can start kind of distinguishing that, okay, there are some kind of bigger cities. I think this is Paris, that's Madrid, Barcelona, Dublin, London, and so on and so forth. But still not really helpful. How about if I make the kind of major flows thicker, or the lines thicker, and then the minor flows less thick? Does it, oh, what did I do? I guess I did, oh no, I added some transparency and then I added the thickness. Okay, now we're kind of getting some sort of information. So we can clearly see that, okay, yeah, Paris, Berlin, Dublin, and kind of bunch of cities in the Mediterranean or Southern European regions are kind of the main receivers or senders in Erasmus student mobility, which is not surprising if you kind of know where the whole program started. Basically, collaboration between Spain, Portugal, and Italy, I guess, and France. But still, I wasn't really happy, because this really doesn't show in a nice and clean way like how these flows are distributed there on the map. So I was kind of bummed out. Obviously, you could use this, and maybe some would say this already looks kind of nice and cool, but I wanted to make it even better. So I went back to the drawing board. So just realizing that when you put this many lines on a map, it just like doesn't really work. So you like either you get this massive hairball, or even if you try all kinds of visualization tricks, you still are obscuring some of the background information. Obviously, it's background information, so it's not like primary interest. But still, like I would want to be more like I would like it to be more clear that okay, this is actually Paris, so the map reader shouldn't have to guess. And obviously, directionality is murky, but like with any sort of mobility data that is this massive, if you start adding directions there, you're just asking for more trouble. So what I then did is I talked with my colleagues, and we kind of tried all kinds of stuff to figure like how we should do it. Should we do it like on a country level? So we couldn't put every line on a map, and we would just do a country by country basis, like where they're going and where they're coming from. That's one option. Or should we do something else? And then, like per chance, I stumbled on social media, just super randomly, on a post by some guy, I guess some Danish guy, about like some R library. And I don't use R, but something caught my eye, because here they said that, okay, spatial networks. And hey, actually, the student mobility is in a way a spatial network. So we have we have like end and start nodes and lines between them, and then this edge bundling techniques. And I started thinking, okay, what is edge bundling? I've never heard of that. So then I clicked on the link and realized that, hey, it's exactly what I need. So it's a technique where when you like tailor-made for situations when you have a bunch of lines going every which way and you want to kind of reduce visual clutter to make it more understandable. So obviously then I started digging a bit deeper, and unfortunately I didn't know R, or like maybe like the very basics. I can open a file in R and that's about it. But I started digging and I found that, okay, it's kind of a lot of it's based on this kind of semi-recent paper by this Wallinger guy, and they or the work group there basically, and where they had done this kind of rather comprehensive review of different edge bundling techniques on like which is the best to kind of, if you want to preserve like the directionality, so lines that are going to the same direction and have a similar origin and destination, so they should be bundled together, whereas lines that are going kind of in opposite direction should kind of be bundled separately, and like these other approaches do not really kind of account for that. So we selected this edge path bundling because it was deemed to be kind of in this paper the best. And luckily I found a random GitHub repository where somebody had actually implemented this in Python. So what we did is we implemented their implementation of edge bundling to our use case. And we tried it on our data, and already I was kind of happy. We got this, it's still a hairball, but it's now less cluttered. So okay, let's like reduce the line width and like make the higher flows or the major flows more bright, and the minimal flows less bright. All right, looks already quite nice. Let's add the kind of line width thing there. Okay, starts looking even better. And then like to just make it super clear to the map reader, let's add like these little circles to the end, so people actually can kind of pinpoint where the flows start or begin, and then just tinker with the visibility. And this is kind of the final map that I was really happy about. And then obviously I needed to add a legend, and I was kind of happy to be able to do it and go from this really ugly looking thing into something rather fancy. And just to show you kind of what I showed in the beginning, so it's not a straight line. You kind of have to go back and kind of readjust when you realize that, okay, you're not getting what you want. So that's the core of my presentation. And if you're interested in what we did, so the tool that we then developed based on edge bundling, it has this animation thing built in. So if you're working with mobility data, so you can also make these animations with it if you want to impress, I don't know, colleagues or friends or family. So there we are. Thank you. That's.
Thank you. Very, very interesting presentation. You're a very good cartographer. I'm a big fan. So.
Oh, thanks.
Do you have any questions from people?
So
Yeah.
you have used the Python code
Yes.
to make it more better than the GIS version?
Like you mean with the edge bundling?
From this to this, it's because of the Python.
Well, yeah, this is just the raw, like straight line geometries, because when we started, we just have the, like in the raw data, we just have an origin, which is like a region in Europe, and a destination. And what we did is we just made like used these two coordinates then to create a line. And that's kind of the basic raw format of the data. But what we then realized, as you can see, when you do that 2.5 million times, it goes, or it's not very kind of legible. So then what we did is we tried to visualize the straight lines as well as we could. In some certain instances, this could also be very acceptable. Like, I'm not saying that, but like we wanted to make it a bit more fancy. So luckily, we found this edge bundling thing, and there was like a random GitHub repository that had implemented this edge path bundling technique in Python, like from this paper, or was it like from this library? I don't know. I don't remember anymore. It's like 2 years ago already. And we just tried it out first, and then when we realized that it actually works, then we kind of modified that original script, Python script, for our purposes, just to make it easier to use with exactly geospatial data. Yeah. So that is the thing that is available, like here. Oh, really? Let's see. It should work. It goes to Zenodo. Or is Zenodo not working? This should bring you to a Zenodo repository, which has the code. And then there's a GitHub repository for it as well, but the Zenodo one is the one with the DOI, so we can get references like in academic circles. If it doesn't work, then I can maybe even like send you the GitHub link and you can disseminate that.
So is Zenodo down, or what is the problem?
I guess like even for me, it's not loading. Like
Okay, maybe it's the Zenodo.
it's in Switzerland. Who knows? Like it should be in CERN, so that's weird. Yeah, bad gateway timeout. Did you get the same thing?
Yeah.
Yeah. Like it's out of my control. Sorry for this. Does the above link work? Does it bring you to? Yeah, I think it brings you to scientific data. That's good.
Yeah. You have a question?
How long does it take to bundle that images? Like, is there a problem with the purpose?
Yes, it took a while. So I was at work at 4, and because I knew it would take a while, so I pressed button to make it go, and then I went home, slept, and came back in the morning. It was done for this. But obviously, if you have more, then it will take longer. So this was, I think, for these 2.5 million flow like lines. So this took, I would say, like 6-ish hours. So my computer, like desktop here, was just on full blast for 6 hours because it's intensive. But if you have less complex flows, so here this is like, sorry for going very technical and EU on you. So this is based on these NUTS 3 regional level of the EU. So the EU has this standard regional units, and I think they have like 1,300 something units all over Europe. So from each of those regions to each like all others, so it's like 1,300 times 1,300. So you get a massive amount of lines that you have to bundle. So it took a while. Obviously, we simplified it because student mobility flows do not go from everywhere. Like there's like Svalbard Island and kind of these Arctic ones, and then like France has some like overseas territories in Latin America and on the Indian Ocean. So we kind of took those out because they were just like complicating it way too much. But still, yeah. But if you have something very simple, like let's say a few hundred unique origins and destinations, then yeah, a few minutes, I would say. Yes.
Did you try experimenting with direction?
Yes, I did. And then like the trouble with this type of data, especially the raw data, is that when you have, let's say, something that goes from, like, let's say, Helsinki to the Canary Islands. So like depending on the direction, like geometrically, the line is identical. It starts from the exact same location as the other one ends, and vice versa. So in QGIS, there's like some couple of neat tricks you can do with the geometry generators. I'm not sure if you've done that, but where you can kind of where it recognizes, okay, there's a line and there's or two lines that are overlapping, so it can kind of artificially kind of make a bow on them. So kind of bends them, and then you can add arrows like indicating directionality. But with this type of data, you're getting so many arrows going all over the place that it doesn't work. So if you have small enough data, then it works perfectly. But like with this, it just doesn't work. And what we ended up doing is basically we're not these are not like directed flows. So these are just like if it has the same origin and destination and vice versa, we just sum them together to kind of indicate the level of connectivity in a way, just to make the map work. So now that you, sorry, did you have something?
No.
I'm just curious, now that you kind of have learned about visual hierarchy and so on, so is there something that you would do like in addition to this? Like, do you think, well, at least my personal opinion is that at least the major flows, they pop up nicely, but is there something that you would do differently? Is there something that is annoying you? And before you say there's a scale bar, but it's barely visible because of the lighting situation, but yeah, it's clearly visible there. Yeah.
Maybe with legend, it's not so readable, let's say.
Yes.
I understand that it follows the color of the
Yeah.
let's say. It's not
Yeah.
really
Yeah. That is also something like a good cartographer. Also, like I should have also kind of taken notice of, okay, I'm coming to a classroom which might have overhead lights and like not necessarily the best projectors. So exactly making the font sizes bigger and kind of using maybe bold fonts or whatever. So that would have made it legible. That's a good one. Good. Anything else? Because
I also have a question regarding this.
Yes.
Was there a reason you have put the legend on the right side? Because there seems to be more free space on the left side. So was there some thought to it, or?
Well, I think this is just like from a force of habit, because quite often, like in some of these other flows, some like these flow types that we have in the project, like migration and seasonal work, you also have stuff coming from like Iceland to like the, what are these in English, like the Madeira Islands and so on. So you have some flows going over here, and nothing so much like on kind of this eastern side. So just like that reason. Obviously here I could have put it there as well. Is there some sort of like
No.
literature saying that it should be kind of like?
No, it looks nice. I was just curious, but was there an agenda behind it?
No.
So if we're reading from left to right, then
Yeah.
the left would pop up more than the right.
Yeah. Obviously, you can then make the argument, okay, I want people to first look at the map and then what it says. But then, like, that's also like a very subjective decision that you have to make, like, depending on like when you know that, okay, the audience will be like, let's say, Finnish, and if you want the Finnish map readers to first read what the legend has, then it's an informed choice to put it here, kind of before they read the map. Although I'm not sure whether even people would still read the legend before the map, yeah, especially if you put like super nice colors on the map. So, and also quite often, like that's a trick. Like legend, obviously, it's important for interpreting the map, but it's still secondary to what is actually on the map. So there's also this balancing act that you have to do in kind of making the legend kind of there and readable and understandable, but still, if it's super ornamental, like in some of these historic maps where you have like these all kinds of ribbons and fantastical creatures around the legend and so on. So is that then drawing the eye away from the map to the legend, which is just a supporting element for the map. So also something to consider. And yeah, I just going back, I highly recommend the where's this book. So if you're at all kind of enthusiastic about cartographic visualization, I think this is, even though it's like over 10 years old, it's still very current. So
Yeah, I guess if there are no questions, then
Thanks.
we can finish here. Thank you very
thanks.
much. Actually, next week we are going to use your data. You remember you shared it with us a
Oh,
while
yes.
ago. So you can, hopefully you got some ideas from here. You can practice it next week.
Great.
Yeah, thank you and see you all next week. So we'll be having the lecture as usual on Tuesday.